So thank you for coming to my talk. So working towards PyIceberg 1.0. My name is Fokke Driesprong. I work as an open source software engineer at Tabular. I'm also a committer and a PMC on the Apache Iceberg project. I'm today on holiday, but I definitely wanted to take an opportunity to talk here today. So yeah, great to be here. As always, like it's always already being said, but so many big names and also the whole thing looking so professional. It was back in 2019, just a trip back on memory lane when I first contributed to Iceberg. It was working on the Apache Avro project. Back then it was not really maintained anymore, and I wanted to get like the Java 8 EASR 3.10 in there. For those not less familiar, before you had like use an external library to use Java time. Yeah, to have like a nice API around time objects, and now in Java 8 it was being pulled inside of Java 8. So that was actually my first interaction with Iceberg, just to bump this to see like what's going on there, also to get like more familiar with the project. And actually it uncovered like a bug in Avro that was otherwise would be gone unnoticed. So that was a great way of getting acquainted with Iceberg. It's already like 4 years ago, so I'm excited to see how things are going. So for PyIceberg, who are not familiar with it, just like to set a bit of the definition. So the goal of PyIceberg is to accelerate the adoption of Iceberg in the Python ecosystem. Iceberg itself, while it has a very well-defined spec, it can be quite a challenge to get everything implemented, especially outside of the JVM. For the JVM, there are a lot of Java packages already available that integrate with different query engines, and also just the whole scaffolding is available on GitHub. But for Python, there was a bit more it was not there. Also, evaluation of whole metrics, it can be quite challenging because you have to implement the whole spec. Also, like Avro is not a very common file format in Python. So we actually decided just to help the Python ecosystem by developing this library that can be plugged into different engines that we have in the Python ecosystem, just to do query planning of the Iceberg tables for you. Another important part there is that also when we think about Python, we often think about like data science, and that's a different kind of approach. Like data engineers, they all think about like systems and integrations. And data science, they tend to be more have to focus on models, and how can I get like this piece of data into my memory so I can like model some kind of data science model on top of that. And this is also the area of a different paradigm, I would say. For example, like the whole concept of a catalog, which is very important in Hive and later also Spark, did not really exist into the Python world. And also a lot of people had a lot of pushback around like, oh, why do we need this additional thing there? For reading, you actually don't need it. But if you want to write, and the commit path of Iceberg is through the catalog, so then it becomes very important. So the whole idea of PyIceberg is just to take all these concepts and also do all the hard work, and just to give it like as a library to the Python ecosystem. Where does it lead us? So I always love this chart. It's my favorite vanity metric. It's like the number of downloads on a single day. We see that last week we surpassed like the 50,000 downloads on a single day, which is quite impressive. But on the other hand, like I always try to take this a bit with a grain of salt. Like also some projects run PyIceberg as part of the CI/CD, and then it's really easy to blow up these numbers. But I'm very happy with like this upward trend that we're seeing. And hopefully it will continue with all the help from the community and everyone adopting it. So before we look ahead, just a quick look back, like where are we today? It started in September 2022, and this is actually where PyIceberg started. Before there was already like a Python project as part of the Java repository, but it was never really used, and it was actually very much like a port of the Java code into Python. So it was not really Pythonic. It did work quite well for Netflix, but just to also get more adoption into the Python community, we actually want to rewrite it into a more a Pythonic fashion, I would say. So the first I was like 2 or 3 versions were very much focused on the read path. So we got like the concepts of like the catalog in there, the whole read path, where we did like the evaluation of the manifest list and the manifest files itself. And then I would say roughly version 4, that's where we started working on the commit path. So this was actually updating the tables and your Iceberg tables. Started very simple by just setting like properties on the tables, and later on, where we are today, we can also do writes, which is actually writing new snapshots to the table. I'm very excited about 0.7. That will bring like full write support also to Python. And at some point, of course, we're also going to look ahead today to version 1, which will hopefully, I think, should be reasonable, be released this year. But let's see how things progress. If you want to give it a try, there's a Docker composer that you can just start up very quickly on your own machine. It will give you like a REST catalog, MinIO, S3 backend, and a Jupyter notebook. And here you can play around with the PyIceberg and also check out the whole API. Let's give a quick overview of the typical applications that we have for PyIceberg. I think one of the first things that we implemented was like a CLI to inspect the tables. It was not really available for the Java. Yeah, for Java it's always a bit awkward because you have to have the jars and the JVM, and just pip install PyIceberg is much easier. So that's where we started. It's also a nice way of interacting with the catalogs. Next, also data processing came into scope. This started with reading in the data into an arrow table, but now also extended to different query engines that I will talk about in a moment. Pluggable query planning. So this was really the core of PyIceberg, that we actually make the whole query planning. You have some kind of expression, you plug it into PyIceberg, and PyIceberg will tell you like which files you need to read. We can see that also in a minute. Migration. So PyIceberg supports a lot of different catalogs. So especially people that want to migrate to a different catalog, with PyIceberg it's very easy to, for example, keep different catalogs in sync for the time being that you're doing this migration. Also orchestration. We already mentioned Dexter in the comments, but of course, we also have my personal favorite, Airflow. I'm a committer on Airflow as well, so that's why. That I think it was 3 days ago we got like the Iceberg provider in. Previously it was already like the Tabular provider, but the Tabular provider and the company that I work for didn't have any Tabular specific things in there. So we actually decided to rename it, and there was great work being done by Ron Sharon that actually renamed it from the Tabular provider to the Iceberg provider, so we can build more open source things on top there. So the main thing is that it integrates with REST catalog. So for example, we can have specific workflows that wait for a specific state of a table, or actually do some data processing on top of an Iceberg table. Another example is Polars, which is a Python data frame library. This is actually, I think, a really cool implementation because it's also lazy. So what you can see in the top right is some small piece of Python where we first load the catalog in PyIceberg, then we actually load the table and we start a scan. And at this point, we don't really fetch any data yet. But what it will do in Polars, you can actually do some steps on the data that you want to, how you want to process, which columns you want to select. And once you actually hit an action, for example, you pull everything into memory, then it will actually push like the predicate up to PyIceberg. PyIceberg will evaluate the predicate against the Iceberg metadata and only return the data that's relevant for the query. And also here, the whole concept of a catalog was not really super common within Python, but also here we can see that we can just load the table from the catalog and push it in there, so we can actually really nicely just integrate this concept of a catalog there. Another query engine that got like PyIceberg in the backend is Daft. It's a Rust-based, same for Polars, by the way, query engine. But the nice thing of Daft is designed to scale out. So you could see like the lightweight data processing, the lightweight was striked out, and that's because with Daft you can actually pull in like quite a significant amounts of data. It's quite impressive. So if you're interested in this, I would just refer to the talk of Jay and Sammy. We're happy to tell you more about Daft. It's really cool. We can also see a different thing. For example, this is a data hub where you actually have data cataloging. This also uses PyIceberg in the backend just to interact with the Iceberg tables, because Iceberg already has like a lot of metadata in there. We can actually compute a lot of statistics, for example, the upper and the lower bound, the number of nulls, these kind of things, without actually querying the Parquet data. So this way you can actually quite easily get like a nice overview, a nice catalog of your tables, and you can also see like how what the distributions are of the columns and these kind of things. Another one that I really like is dbt-duckdb, and I promise this last one. What it uses PyIceberg in the backend as well. So to actually, you can actually set like a row filter for each of the queries that you in dbt they call them models. You can actually push it down into PyIceberg, and it will only pull in the data into DuckDB that's actually relevant for the query. I think this is also a really cool example of PyIceberg. So I always like to look back from a technical perspective. So some things that we did along the way. My personal favorite is removal of tox. Tox is like a virtual env tool for Python. I think it's very obsolete, and we migrated to Poetry. Especially because Tox also very heavily relies on virtual environments, and personally I think you can just use Docker for that. It's a matter of taste, I would say. Also, Poetry has like ways of setting up a virtual env, so it might I think this might the development a bit easier. Pydantic for the JSON deserialization. There was quite a controversial suggestion because in Java, all the JSON deserialization code is just written by hand, and with Python, I said like maybe use this library. I think we still made a great decision there. The only thing is, with Pydantic 1 to Pydantic 2, there were quite a few breaking changes, especially if you try to downstream PyIceberg into other projects. This can sometimes be a problem. For example, in Data Hub, the cataloging tool, we can see it's still at Pydantic 1, and it takes quite a bit of time to get this upgraded to Pydantic 2. So that might actually block like the adoption of PyIceberg. Nevertheless, I don't really like writing all this deserialization code, so I think we made a good decision there. Another thing I think that also Ryan told us, like, we also got like a lot of things that we did in PyIceberg that actually improved like the specs. On the left hand side you see like all changes to the OpenAPI spec that were actually incorrect, and we noticed this when we started doing like the second implementation, because Java was the first one, and then we started doing Python, and then you notice all these discrepancies. So we actually found like a lot of discrepancies there that we could actually remove there. And also when I did like the Python writer, Ryan said like, he did like the reviews like, this is cool. So he also did the same concept into Java, and I think this also helps to improve the code quality in general in the end, for the whole Iceberg project. One thing that we're still a pure Python project. We have actually one Cython part in there to read like the Avro files, because Avro reading is quite inefficient because the way integers are encoded, you have to do a lot of calls. Their variable length. So we might need to do multiple calls to read like a byte stream. This is not something that Python really excels at. So Rusty actually did some really cool work on converting this part into Cython. Actually speeded up the reading of the Avro quite a bit. Currently we have like a fallback, so if you don't we compile like all the binaries for your specific architecture. But if you have a very new or very like a special architecture of CPU, and we don't have the pre-compiled binaries, then today you can still fall back to a pure Python implementation. Maybe I would say maybe at some point we should maybe reconsider this, because I don't think it's a real blocker for most of the people. But would love to get your opinions on that. So we look back. Now we're going to look at where we are today. So today we have a full-fledged read support. This includes positional deletes. So if you do merge on read deletes, which means that sometimes you're in a streaming situation or something, you don't want to rewrite a lot of the Parquet files. What you can do is like positional deletes will tell you this Parquet file, this position, this row should be considered deleted. So you just put like a mask on top of it. And for equality deletes, you will say like, okay, this predicate, for example, this more, if you think about like as a traditional database, this primary key is being considered deleted. The positional deletes are quite easy because it only affects like a single Parquet file. With equality deletes, you actually have to find out when the files were written, and you have to actually apply them. So they're a bit more costly. For PyIceberg 1.0, we might want to implement this, but let's see if someone actually asks for it first. So for support for writing unpartitioned tables, this is a very popular thing, of course. So a lot of good stuff going on here. Writing for unpartitioned tables. Yeah, so this is in there. So if a table is unpartitioned, you can just write to it. Broad catalog support. I think this was also with the question in the chat. So today we have REST, Glue, Hive, DynamoDB, SQL. SQL is the equivalent of the JDBC catalog. And we also have the Snowflake catalog in flight and the Big Lake in flight. And maybe also Nessie. But we see also a big trend in the industry that people are actually adopting the Iceberg REST catalog. And that's already supported. So that would, especially for Nessie, for example, if that's in flight, if they will implement the REST catalog in a few weeks, I would suggest not implementing that as a separate catalog in PyIceberg, because it gives all code that we have to maintain again, and not all the catalogs are equally popular. So I think we have to, as a community, we have to make some decisions here. And also, I think what's really cool is that we have the schema updates. And you can do this using union by name. So actually a lot of the logic that we have with PyIceberg is where we track like fields using field IDs actually being pushed down into the Python library behind a very nice API that we call union by name. So you don't have to think about the whole IDs at all. If you're interested, please check out the docs. Looking forward, if you're interested, please check out the milestone. Try to keep it updated. So the biggest things in there are write multiple files per partition. This has been implemented by Kevin from Stripe. It's a really great feature. What actually allows is if you have a very big table in your memory and you want to write this out, by default it was just writing one file per partition, and if it's unpartitioned, it would actually write for this single write operation to one Parquet file. This can take a very long time because write to Parquet is quite hard to parallelize. So what Kevin actually fixed is that we actually write it to separate files, and this way we can actually parallelize it. If you're interested, please check out the PR. Also show some benchmarks there. Partitioned write, some great work by Sung and Adrian from Bloomberg. What we ran into, I think the most, maybe just some context why it was not as trivial as it looks. If you have big tables, you have a lot of data, right? Applying the partition function can also be quite expensive. So Iceberg has some special partitioning functions, for example, the bucketing transform, that are not just available out of the box from Arrow. This way we looked at like which ones are available today. Identity is already in there. Year, month, date, hour is an open PR, where we can actually just use the Arrow functions to truncate these fields into the right partition formats. This will make sure that it keeps that the writing of the data becomes performant, and we don't have to go back to Python and the C layer of Arrow all the time. Partial delete, something that I'm personally working on. gives us a static overrides merge into for free. Tell something more in a minute. And metadata tables, I think this is also great. Also a lot of community support here. One big thing is we made the nested field optional by default. So it was actually required by default. And it was quite awkward because if you create like a table from data in memory, for example, you have an arrow and say like from Python dict, it will actually make everything optional. While it could have checked like that there are no optional fields in there. But if you would write this to the file, it would say like, okay, by default, if you would have crafted the schema by hand, it will say like, okay, this is required and your scheme of your field is actually optional. So we're gonna fail. And just making this optional, that's great work by Mehul Batra. Yeah, it's just much easier and you don't get in all kinds of awkward errors. And it's also more in line with the rest of the systems like Arrow. And of course, many small fixes. I always very happy with these small fixes. Of course, it shows like there are bugs in there, but it also shows that a lot of people are using it. So yeah, keep them coming. So a bit about the partial overrides and how we implemented this into PyIceberg. It's actually a 3-step process. In this case, we're looking at the partial override. So it will first actually delete like the data that you're trying to override, and then it will append new data. So in this case, for those that are familiar with the metadata tree of Iceberg. So first you have the catalog, for example, REST catalog or Nessie. You take the pointer to the latest metadata file. Actually, with the REST catalog, it's a bit more simplified. You can just get this file from the catalog itself. You look at the snapshots. In this case, we're interested in the newest one. We look at the manifest list. And here we can actually already evaluate if something that we're trying to delete, if it's in one of the manifest files. If it's not in there, we can just copy the manifest files because it's data that we want to keep. And if there's relevant data in there, we'll just go to the manifest file and we'll first check without checking the data files if we can drop the whole file. If this is the case, we will accumulate these deletes into a delete operation. And if we detect that there's relevant data in a data file, in a Parquet file, but we don't know if we cannot determine if we can drop the whole file, we actually will look into the file to check if there's relevant data. If this is the case, we do actually a copy on write. So we'll take the file, delete the relevant rows, and then write a new file. And when this happens, it will be captured in an override operation. So now we've deleted the old data. And yeah, if you do a partial overrides, you often also want to write some new data. And here we can use, we can just do an insert. We create an append operation. So we can see this is 3 operations, but it's very important that we just take these 3 operations and we push them into a single commit. And that's being going back to the catalog. So these operations are being pushed atomically to the catalog. And you get like a nice consistent snapshots of your table. Now we're actually looking forward. PyIceberg 1.0. I'm very excited. It will be the first major release. It comes with a lot of responsibility, of course. I think what's important is the table maintenance features, API stability, and also better interoperability with the rest of the ecosystem, because that's our long-term goal. So for the table maintenance, at the current main branch, we actually implement a lot of the metadata tables. And what this is that when you have a table, here we can see we create like a new table, defaulted animals. We insert like the flamingo, parrot, dog, and a horse. And we actually append this data to the Iceberg table. And what it shows us is that we can get like a list of snapshots. In this case, we see like one single snapshot. This makes it really easy to implement like table maintenance later on. For example, expire snapshots would be just like a filter on this table just to see like, okay, how long are we going to keep history? I think by default 7 days or something. After 7 days, and all the snapshots, we can mark these for cleanup and we can remove them. What I'm personally very excited about is ferrous onto the iceberg. For those who are familiar with Rust, you will recognize ferrous the crab. I think iceberg of like Python and ferrous will be a very good combination. First of all, if you want to go into the details, please go to this talk from Renji. He's really good at Rust and really wants to give you all the details. I'm here more to talk about like why I think Python and Rust are such a good symbiotic relationship in this case as well. And that's mostly because some limitations that we ran into. The biggest problem is that field IDs are not widely supported within the rest of the ecosystem. I think this is a major it's very sad to see, because I think it makes like the reasoning about like what Ryan's always saying, like thinking about like from a database perspective, keeping tracks of fields by field ID instead of name. Names can change, field ID cannot change. Makes a lot of sense. But yeah, the APIs that we find in most of the Python libraries are not they're based on names and not based on the field IDs. So what we actually would like to see is like that we can say from this Parquet file, we want to read these fields based on field ID into these types. So for example, when you change like the order of a field, some systems are even positional based, or if you rename a field, then this all doesn't matter and you still get like a consistent result. So what we do today in PyIceberg is that we take, for each of the Parquet files, we actually create like an arrow table. And then we actually concatenate all these arrow tables into a single table. And this is because all the Parquet tables could have like a different schema if you do a lot of schema evolution. This is not supported right now. I think at some point, especially when Iceberg-Rust gets more mature, we could push this into Iceberg-Rust, and that would actually make things much easier. This is the big yellow elephant in the room. Yeah, so this is the symbiotic relationship between Python and Rust. So in PyIceberg, we actually have the full metadata layer right now. And in the data layer, we currently hand this off to PyArrow. Maybe in the future, we can do this to PyIceberg-Rust, where we can actually have a better API between this. So we can have a very strict separation between these worlds. So for example, PyIceberg actually looks into the Parquet files just to get like the schema of it, and then we make like an of ID to name mapping just to make sure that we resolve all the fields correctly. This also ties in with another long wished feature from the community. It's exposing the PyIceberg table as a PyArrow dataset. Arrow, you have the table, which is like a eagerly materialized construct, and the dataset is actually a lazy construct, and this integrates very well with Iceberg. There's a long discussion about like also from the Arrow community, like how this should integrate this. This is like a very bit older proposal of having like a minimal protocol for a dataset, and then in PyIceberg we could actually implement this Python protocol and act this as like an Arrow dataset, which I think would be very powerful. But in the end, I think after some community sync from the Arrow side as well, they actually went more for a substrate approach, where you can still have like a protocol, but then the connection between the API between PyIceberg and Arrow is through substrate. For those who are not familiar with substrate, it's actually a way to express filters, expressions into a language agnostic way. And the C data interface, then what you would return is like Arrow buffers, which would also work very well with Iceberg-Rust, I think. Yeah. So this is more, it's very small, it doesn't matter. Like how to, if you're interested in this, I would check out this PR at least, and also maybe look into Substrate. I think this is a nice way of implementing it. Another thing, in the end, it makes sense, but that's always like looking in the rearview mirror. Like we should have maybe looked into the API a bit more. So this is it today. So we actually have these different nicely separated it's called modules in Python, where you have like the schema and the types and the catalog. But you have to do a lot of imports. You have to recall all the names. So yeah, this would be one way of improving this already, where we, similar to Polars and PyArrow, where you actually have one single import. And this way, yeah, everything is just nested and the top level. I think that might also make the API a bit easier to maintain. And if we can all the way, then we could also have like, nicer aliases, just to make it a bit easier for the user. I'm pretty sure that you'll be able to do this from the top of your head, while this might be still, might require some looking up of the docs. Also important when we go to 1.0 is that we actually detect like breaking changes. Right now sometimes you still break some APIs, something, because of, for example, also the partial deletes requires quite a bit of a refactor into the code. I think for now that's okay-ish. Often these APIs are a bit more internal, but definitely the public API, we should make sure that we don't break it. And if you don't test it, then it's going to be broken. So I would love to see this PR once we go to 1.0. Some more things. I think this is a bit more like, I would love to get like the community's thoughts on it. We have Eduard Teutenhoefner, who is going to talk about Iceberg views. Views are very SQL based at this point. We don't have this in PyIceberg because we're not really based around SQL, we're mostly based around data frames. So maybe at some point we can maybe get conversion in there. I don't know, like I'm open to ideas, but I would love to also support SQL of our views at some point. And also Puffin, it's also like an excellent talk by Nick from Bodo. So if you also look at the Puffin, like it's also very, it's also a bit like, it has these Apache sketches, so we also have to see like if we can convert them into the language that we're actually using the query engine. So this is also interesting to look into. Maybe something for 1.0, I would say. So before my final slide, I would just want to thank like the whole community. It's great to see so many people around. I think also I saw some names in the chat as well here. So thank you for that. It's really awesome to see so many people interacting and coming everything together. It's a big milestone, I think, with once we get like all the right support in there. Question I get often, like, want to get involved, like, how do we get started on PyIceberg? The easiest way is just to start using the project. So if you have like some pet project or you want to do something on maybe in your day job where you want to use PyIceberg to store some data, I think this is the easiest way to get started, because you run into very actual real problems. If you just go to the GitHub, you have a whole list there as well. Recently today added by Kevin. Thank you for that. Where also like a lot of things that we try to add like to roadmap a bit to the repository. But if you run into something yourself and you fix it yourself, that often it's much easier. It also gives more satisfaction. So just a tip from my end, but feel free to jump in. And that's it for me, actually. So this is my daughter. It has like a great shirt by Megan from Tabular. Thank you for that. And so this is my email address. I'm also on the Slack. Feel free to jump in if you have any questions or anything.
Okay. Thanks, Paco. That was awesome. So we had a couple questions going through. I'm trying to find the one. So there was one recently asked about substrate, which I think that's more of a view-focused question. We find some of these more recently in the Q&A, I think, that are a little focused. So one that was asked before and then also got pulled up in the Q&A was the Dremio Nessie catalog support is present. And so I answered that here, but feel free to just kind of mention that so this is on the recording.
Cool. Yeah. Sorry, I was also reading into the thing, and then I realized again that I cannot multitask.
So, yeah, kind of a echo.
Any questions? Someone wants to jump in? Rob, I'm still kind of confused of where the computing power of PyIceberg comes in. So in the situation where you need to query big iceberg tables quickly, where Trina comes in mind as an option, how would you go use PyIceberg instead? Could PyIceberg do the job? Is something else needed? Yeah, so PyIceberg by default, it comes with an arrow backend that you can actually use to read in data. But yeah, of course, this backend arrow is memory focused. We don't have the dataset implementation there. So right now that's limited to your memory, I would say. We see some new projects coming up, for example, with Daft that actually can scale out and can process a lot of data. So yeah, if you're interested in that, I would definitely recommend like the talk by Jay Daft. That's actually linked in the presentation. That's a very good. He will definitely go into details there. Yeah.
Hey, Fox, can you hear me?
Yeah.
Okay. So we talked about the NSE one, partial overwrite. So it's saying like, do we overwrite? This will be which type of tables, V1, V2. I thought V2 creates positional delete file, but then actually I just lost Paco. Let's see. Okay. Well, in that case. So I can do my best of, I'm actually getting like an echo in my own head. I can do my best at answering the partial override thing. Okay, actually, Faco's there. Okay, Faco, you want to talk about partial overrides, difference in versions, and things like that? There's, if you go to the Q&A tab, there's a question you can kind of get more specifically what
partial override. The partial will create type of tables. Yeah. So that's a great question. So we support partial overrides on V1 and V2, but we actually don't take the advantages of V2 because we don't support merge on read. So when you do like a partial override, it will create like a copy on write. So it will actually, if they have to rewrite like a parquet file, it will actually write a new file without these rows that will be deleted. So a next step indeed would be like to also produce positional deletes or equality deletes to also support merge on read situations. Does that answer the question?
Let's assume so. Reply there, Nadine, if you have any follow-up questions. Martine has the question on hierarchical tables. Want to get that one?
Hierarchical table names.
Yeah, hierarchical table names in PyIceberg 1.0. So like namespace 1, namespace 2, parent.
Okay. Yeah, we support hierarchical namespaces, so that's already in there. That's both for the REST catalog and the SQL catalog. Yeah, so I got a bit confused because hierarchical table name. So yeah, we support like multiple namespaces. Yeah, so we can actually have nested namespaces.
Okay, so if you could follow up on that, Martine or Martin, just let me know. What is the reason for not supporting the Hadoop catalog via version hint text, or is it supported?
Yeah, that's a good old one. Yeah, so the Hadoop catalog is actually when you commit to write to a table without a catalog. And this is actually relies on the version hint.text, but actually points to the latest version. But it's actually not. Yeah, it's a way of circumventing. Okay, let me take one step back more. Iceberg was designed to work with object stores, and this version hint.text is actually was a walk around. Like I think Ryan would say like a partial solution after his talk today, like to support also HDFS and not needing a catalog. Yeah, so it should technically still work if you have like an atomic file system, similar with AGFS. But when you go to an object store, you don't have any atomic operations anymore. So then you actually need to have something like a catalog to enforce the atomicity of your commit. Otherwise, you will, get into race conditions, and that will lead into data quality, and that will lead into tiers.
Okay. I'm gonna quickly get this Rust one first because I think this answers a lot of other people's questions before, and I'm gonna jump back up to Rob's question just after that. I think it'll be good to dive into that. It's a very common question as well. This is thinking about, like, at some point I mentioned, we'll probably have Iceberg-Rust, a lot of PyIceberg stuff built on the Iceberg-Rust code over time, because everybody's thinking like, well, why did we just have a fully pure Python type of implementation? And I just said historically, right? We started out before Rust was really in the data space, and now we have a lot more people who know Rust that are able to help us contribute there and that kind of thing. So, so we're going to end this session in three minutes. So hurry up on this answer, Marco, and we have one more we can try to grab.
Is it
Marco, are you there?
Yeah.
Okay.
Sorry, any specific question in mind?
The question is kind of like, when will we be moving into like Iceberg-Rust, I guess, because that is, I think, the idea. Is 1.0 part of that, or is that going to be probably on the line?
Yeah, that's a big question. So I think we have to align there also with the Rust community. Just how we're gonna, because at some point the Rust community will have like a Python interface, a front end, right? Will this be like PyIceberg, or will we have like a very thin layer there? Because I think a lot of it, also with Arrow and also with like a lot of the Rust layers where you have like a very small Python shim. This also limits your things you can do in the Python world, because these Python objects are just a reference to the Rust object, and they don't carry any Python information at all. So I think we have to do some design thinking, like how would we see these kind of things. For me, maybe we can also just take a layer of it. I think when I showed like the slide of having like the query planning part, I think that should be PyIceberg, and then actually like the compute part, I think that should be Iceberg-Rust. And I really love the proposal as we saw on the Arrow side, where we can actually make it a Python protocol that's very elegant way of integrating this. So then you can actually have like a data set that comes from PyIceberg, and then we just have like this local system where we actually provide these Arrow buffers into whatever it is consuming. So that could also be like Velox or DuckDB or whatever supports an Arrow dataset.
Okay. I'm going to run Rob's question real quick, and I actually already have a pretty good answer for this. So I'm just going to do it because we're short on time. You're confused on where the compute actually happens. If you have PyIceberg, you can run it locally. It's a library that basically can just run on whatever Python interpreter you have going. Then when you start thinking about things like Trino or something like that, that's already on JVM and pieces like that. You may eventually be able to like let's say you have a query engine like Daft that is building on top of this library, has the ability to kind of put a lot of that compute power from the initial Iceberg statements and effectively running all of that on, say, a Ray runner or something like that. And so that's more dealing with like it actually scales up and goes up to like something that would be highly parallelizable like Ray or any of the other kind of engines. Is there anything I missed in that? Where does PyIceberg end and where does the query engine begin and that kind of thing?
No, I think that's very much it. So that's I think you can all see this very nicely with Daft. We have PyIceberg in the end just gives like a set of tasks to the query engine, like read these files, apply these positional deletes, and these kind of things. And it doesn't have to implement like all the logic of having to evaluate the Iceberg metadata. And also it gets like, as you can see, like all the new stuff that's coming out, it doesn't have to keep up, right? It can just like update to the latest version of PyIceberg, and we'll get like all these developments from the Iceberg project automatically.
Perfect. I think that's our time. I have one other question. I'll reach out to you, Joshua, right after this. Thanks for attending, and thanks, Paco, for the great presentation. Looking forward to 1.00 and making this PyIceberg thing official.
Cool. Thanks, everyone. If you have any questions, I'll be on Slack. Reach out to me. Cool.